The J-16D is a dedicated electronic warfare (EU) variant of the Chinese J-16 multirole fighter. It is part of the broader effort by the Chinese military to modernize its forces, particularly in areas of technology-driven conflict. In recent years, China has emphasized electronic warfare as a critical domain in future combat scenarios, and the development of the J-16D reflects this strategic orientation. The aircraft is designed to disrupt enemy radar systems, communications, and other electromagnetic-based systems that are essential for modern military operations. Structurally, the J-16D maintains the overall airframe of the base J-16 platform, which itself is derived from the Russian Su-30 design. However, the J-16D includes substantial modifications specifically aimed at enabling electronic warfare capabilities. It is equipped with multiple electronic pods mounted externally, typically on the wingtips and underwing pylons. These pods are believed to contain equipment for radar jamming, signal disruption, and other EU tasks. Due to the inclusion of this specialized equipment, the aircraft has had certain features removed, including the internal gun and infrared search and track system. This reduces the aircraft's self-defense capabilities in a direct air-to-air combat scenario, underscoring its focus on support rather than direct engagement. Operationally, the J-16D is designed to fly alongside other aircraft, particularly fighter jets and bombers, providing them with electronic cover. This includes blinding enemy radars, preventing early detection, and disrupting communications and targeting systems. This type of support role is especially important in operations involving stealth aircraft, as EU platforms can extend the survivability and effectiveness of stealth fighters by suppressing or disabling detection systems. The J-16D plays a supporting role that allows other assets to penetrate defended airspace or carry out precision strikes with reduced risk of interception. Despite the increasing visibility of the J-16D in Chinese military exercises and state media coverage, there remains limited verifiable data about its actual effectiveness in realistic combat scenarios. Much of what is known about the aircraft comes from official statements, state media reports, and tightly controlled public appearances. These sources tend to promote highly favorable narratives, often using terms like world-class, cutting-edge, or irreplaceable to describe the aircraft's capabilities. Such terminology lacks objective grounding and should be interpreted as part of a broader information campaign aimed at showcasing China's military progress. It is also worth noting that the presentation of the J-16D as a game-changing platform must be viewed within the context of China's domestic political environment. Public messaging about military strength is often closely aligned with nationalistic goals and efforts to foster public confidence in the leadership. New weapon systems are typically introduced with a mix of technical discussion and political symbolism, reinforcing the idea that China is self-sufficient, technologically advanced, and strategically prepared. In reality, electronic warfare is a highly complex field, and achieving true dominance requires more than the development of a single platform. It involves coordinated infrastructure, adaptive software, real-time intelligence, and the ability to counter highly dynamic threats. One of the technical limitations of the J-16D lies in its reliance on large external jamming pods and visible antennas. This hardware-centric approach suggests that Chinese EU systems may require significant power and size to achieve the desired effects. In more mature systems, similar capabilities are often integrated more compactly, allowing for improved aerodynamics and reduced detection. The presence of large EU pods also increases drag, potentially reducing range, speed, and maneuverability. Furthermore, the emissions generated by these jamming systems can be detected by enemy electronic support systems, which may compromise the aircraft's location and make it a target for anti-radiation weapons. The aircraft's reliance on preset frequencies and jamming techniques may also limit its adaptability in environments where adversaries use frequency-hopping communications, encrypted links, or passive radar systems. The effectiveness of jamming is not only about raw power but also about precision, timing, and adaptability. Without real-time updates and machine learning-based adaptation, EU systems can become predictable or ineffective against modern, networked defense systems that are designed to operate in electronically contested environments. There have been instances where Chinese aircraft have demonstrated aggressive behavior in international airspace, including close intercepts and maneuvers near foreign surveillance planes. These incidents often involve the broader family of J-16 variants. While not always attributed specifically to the J-16D, such actions reflect a pattern of assertiveness in China's aerial operations. The J-16D, by nature of its mission profile, would likely operate in similar zones during periods of heightened tension, supporting broader strategic moves through electromagnetic disruption. The lack of transparency about the aircraft's rules of engagement, combined with its potential for escalating electronic interference, raises concerns about how it might be used in real-world crises. From a military doctrine perspective, the J-16D supports China's goal of establishing dominance in what is often referred to as informationized warfare. This concept places heavy emphasis on the control and exploitation of information across all domains, with electronic warfare playing a central role. The aircraft is expected to fit into larger operational networks that include surveillance, cyber, command and control, and long-range strike platforms. However, without reliable data about the integration and coordination between these systems, it remains uncertain how effective the J-16D truly is as part of a complete warfare ecosystem. Another consideration is logistical sustainability. Advanced EU aircraft require constant software updates, access to real-time electronic intelligence, and high-maintenance electronic components. It is unclear whether China possesses the support infrastructure necessary to keep a fleet of EW aircraft fully operational over extended deployments. Without consistent upgrades and adaptive threat libraries, even advanced jamming systems can become obsolete as adversaries modify their radar systems and communication protocols. The J-16D represents a meaningful attempt by China to establish a credible electronic warfare capability. It marks progress in terms of platform development and doctrinal emphasis on controlling the electromagnetic spectrum. However, its actual performance remains largely untested in contested environments, and its technological maturity is difficult to confirm. Official descriptions of its importance and capability should be treated as political messaging rather than objective assessments. The aircraft's limitations, including potential detectability, reduced self-defense features, hardware bulk, and possible adaptability issues, warrant careful consideration. Until further independent information becomes available, its effectiveness must be judged within the broader context of China's ongoing effort to build and project military strength, rather than as definitive proof of operational superiority.